this video I will show you three algorithms: binary search, bubble sort and quick sort. First of all, let's start with binary search. This algorithm is used to find a certain name, letter, number, etc. Let's start with 3, 5, 8, 9, 13, 24 and 32. For example, we want to find the number 24. Now we have to find the number in the middle, which in this case it's 9. On the right-hand side we will compare the numbers. To start with, 9 is not equal to 24 but it is smaller. So, we will select all the numbers on the right which are larger than 9. I am going to write them again so it is more clear. Now we will repeat the process until we find our number. 24 is now the number in the middle. This time, we compare 24 with our number and it matches, so it took us 2 steps to find our number. Let's try another example. 3, 8, 17 and 19. As you can see, there are 4 numbers, which is an even number of numbers. Therefore, you can use the formula n plus 1 divided by 2. This means that you can find the middle and then the number at the right will be our starting number, in this case 17. Let's say we want to find number 8. So we compare 17 with 8. As 17 is greater, we select the numbers before 17 assuming they are in ascending order. In this case it's 3 and 8. We repeat the same as before, so now 8 is the chosen number. As 8 equals 8, we've finished. So it also took us 2 steps to find the number. Now let's look at bubble sort. In this case we will choose the numbers 3, 1, 5, 11, and 8. I'm going to draw boxes to make it neater. Okay, in this example we will sort out the numbers in ascending order, which is from smallest to largest. For example 1, 2, 3, etc. To begin with, we select the first 2 numbers, 3 and 1. 3 is greater than 1, so we will swap them as the greatest number must be at the right. Then, I will copy the numbers in the same order except 1 and 3 which have swapped. This process is repeated until all the numbers are in the correct order. Now we will compare the second number and the third, in this case 3 and 5. As 3 is smaller than 5, we don't have to swap them. Then, 5 is smaller than 11, so the order stays the same. We compare 11 and 8, and as 11 is greater, we swap them. Once we've finished, we start again from the beginning. So 1 is smaller than 3, check. 3 is smaller than 5, correct. 5 is smaller than 8. And 8 is smaller than 11. So the numbers are now in ascending order and it took us 5 steps to order them. Another algorithm to sort numbers, letters, etc. is quick sort. This tends to be faster than bubble sort, but it is more complex. Let's say we have 5, 3, 8, 1 and 21. We also want to sort them in ascending order as before. So we need to find the middle number, which is the pivot and becomes locked down. This means that it is not going to move. The pivot is used to compare all the numbers and keep sorting them out. We start with 5 and as it is smaller, we don't have to move it. Then 3 is also smaller, so it stays there. Now, 1 is smaller than 8, so we would place it before 5. If you were to organize them in descending order, the greater numbers will go at the left. And 21 stays there as it is greater than 8. 8 is already locked down. We have to find the pivot of the numbers at the left and the pivot of the numbers at the right. Like if we created 2 separate sequences. 5 is in the middle in the sequence of 1, 5 and 3. So it becomes the pivot and locked down. We repeat the same steps. 1 is smaller than 5, so they don't move. As 5 is greater than 3, 3 goes to the beginning of the sequence. Now, as 21 is the only number left in the sequence at the right, it automatically becomes locked down. On our third step, there is only the sequence of 3 and 1 left. 1 becomes the pivot, as there is an even number of numbers, and we will use the same formula as before, n plus 1 divided by 2. So as 3 is greater than 1, 3 is sent to the right-hand side of the sequence, in this case next to 1. In the fourth step, we can automatically lock down 3 as it is between two locked numbers. Therefore, it took us 4 steps to organize the numbers.